Thank you. Well, it is my pleasure to be here today, and I'm going to be talking about mathematics and morality. I do teach a lot of predicate logic, and so depending on your definition of a mathematician, I am a mathematician, and I do love mathematics. However, I'm a philosopher, and I talk in big ideas, and that is certainly what I'm going to do today, big ideas on the relation between morality and mathematics. Here's the outline of the talk. There are 3 parts. In the first part, I'm going to give a very brief historical survey of the philosophical literature, which reveals radically divergent views on the relation between mathematics and morality, even when we restrict our attention to prominent British philosophers in the scientific revolution and Enlightenment period. Then I'm going to offer my view, which is a new post-Darwinian view that mathematics and morality are interdependent co-adaptations that develop over time. Then I'm going to make some practical suggestions, time permitting, saying that integrated approaches to mathematical and moral instruction will be more efficacious than teaching in isolation. And what I mean by integrated and efficacious, I hope to make clear at that time. So, there are 3 possible views you could have. You could say, in theory, math and morality are related, but human affairs are so much more complex than mathematics that in practice we cannot expect to articulate any actual relations. Or you could say they're not related at all because mathematics is based on reason while morality is based on passion. Or you could argue that they're related by direct analogy because the divine author of mathematical and moral rules endowed our minds with the cognitive capacity to recognize both. Now, students of the history of philosophy will recognize these 3 views as belonging to prominent British philosophers, the first, of course, being Thomas Hobbes. Now, Hobbes believed in a thoroughly corpuscularian universe, okay? Everything was made out of atoms, and everything then should therefore be subject to the same laws. But what he argues is he says the perfect knowledge of the truth in all matters whatsoever, geometry, physics, and morals, is what we mean by philosophy. And then he says, and I'm going to turn this into 21st century English, he says, if human actions were as intelligible and easily understood as mathematics, then we could undo avarice and ambition and dismiss all reasons for war, except possibly the one where we run out of resources because there are too many of us for the earth to sustain. Which is very prescient on his part. But what I think is, this view does not work. Because you can ask a toddler which infant in this room is in distress, and they know. You ask a college student, if you put a series of infinite series on the board, which one of these converges to a limit, and they don't even understand the question. So this idea that human actions are not as distinctly known as geometrical figures is a presumption from an academic perspective on academic practices that really doesn't hold in the real world. Okay, the second view, morality and mathematics have nothing to do with each other because mathematics is based on reason and morality is based on passion. This is a moral sentimentalism, and this we find in David Hume. He says, you know, morality is not an object of reason. The only facts of the matter are the facts about your feelings of repugnance when you are faced with something evil. So if you see a willful murder, there is no other fact of the matter in the case. The vice is not in the act itself, as long as you consider the object. It lies in you. Vice and virtue, therefore, may be compared to sounds, colors, heat, and cold, which, according to modern philosophy, are not qualities in objects, but perceptions in the mind. Okay, so he's making this distinction between primary and secondary qualities and saying vice and virtue are like the secondary qualities. We perceive them, but they don't inhere in things themselves. And this view is connected directly to mathematics by Thomas Henry Huxley in his book on Hume from 1897, because once upon a time, great anatomists wrote books about great philosophers. And he says, you know, some people cannot by any means be got to understand the first book of Euclid, but the truths of mathematics are no less necessary in binding on the great mass of mankind. Okay, and this is reminiscent of the claim that Sasha quoted from Lincoln, right? This idea that you don't have to understand it, but it still governs you in some way. And he says, you know, there may be some devoid of sympathy or incapable of a sense of duty, but their existence does not affect the foundations of morality. Such pathological deviations from true manhood, now we would call them people with antisocial personality disorder, an update from the previous label you may be more familiar with, psychopath. They are merely the halt, the lame, and the blind of the world of consciousness, and the anatomist of the mind leaves them aside as the anatomist of the body would ignore abnormal specimens. Except, of course, the anatomist of the body does not ignore abnormal specimens, and antisocial personality disorder is a huge challenge to any moral theory like Rawls or Mills or Kant, which says, well, first of all, what you do is you use your conscience to imagine what it would be like to be somebody else, and suddenly you have a group of people, which by some estimates are as many as 1 out of 25 of us, who can't get to step 1. Okay, there's a book by Martha Stout called The Sociopath Next Door, The Ruthless, and the Rest of Us. Highly recommended. Okay, so on the one hand, though, this distinction between reason and emotion, mathematics and morality, persists in popular culture. So I have 3 representations of these highly rational, good at mathematical entities that are presumed to be absent of emotion. This, do you anyone know this one? Bonus points? Anyone? This is Alpha Soissons, the computer that runs Alphaville and Jean-Luc Godard's science fiction masterpiece. But anyway, we know who this guy is, right? That's Spock, the chief science officer on the Enterprise, and this guy is Data from the Next Generation. And the thing is, though, it's not that Spock is without emotion, but he actually wants or desires to keep his emotions from clouding his judgment. Well, that's a kind of emotion right there. And even Data, who's supposed to lack an emotion chip, he supposedly lacks the wiring to behave in an emotional way, desires to conform to the customs of human behavior, and is really quite pleased when he gets them right, which, if he doesn't have emotions, shouldn't be possible. So I would say that while these figures appeal to the popular imagination, they really do not survive any kind of scrutiny whatsoever. Why? Well, because Piaget was right when he said that all behaviors presuppose instruments and a technique, movements and intelligence, but all behaviors also implies motives and final values, or the sentiments. Thus, affectivity and intelligence are indissociable and constitute the 2 complementary aspects of all human behavior. And so, Hobbes, it won't work. Hume, we like it, it's very popular, doesn't work. So what about Locke? Okay, well Locke says, I am bold to think that morality is capable of demonstration as well as mathematics. Okay, since the precise real essence of the things moral words stand for may be perfectly known, and the congruity and incongruity of the things themselves be certainly discovered, in which consists perfect knowledge. And here's his counterfactual that I find completely fascinating. Were there a monkey or any other creature to be found that had the use of reason to such a degree as to be able to understand general science and to deduce consequences about general ideas, he would no doubt be subject to law, and in that sense be a man, how much soever he differed in shape from others of that name. Okay? And this is the view I find the most plausible if I had to limit my choices to those 3, even though I'm deeply suspicious about this divine author theory. The reason being that I am suspicious of the idea that our ability to perceive mathematical reality is very distinct from our ability to perceive moral reality. Okay. Now, I don't know which James Gibson this is. He might be a Canadian bishop in the 19th century. I can't figure it out. But what he says in his review of Locke's theory and mine is he says, well, you know, I'm going to try and make sense of Locke's theory by putting it in historical context, but I shall not dwell on the obvious futility of the analogy he seeks to establish between the subject matters and methods of mathematics and ethics. And what I should like to convince you of today is that, okay, it may be futile, but it is not obviously futile that there is an analogy between these subjects. Now, if you look online, you find these kinds of claims all over. Here's one from the Annenberg Media Foundation, a charity that exists to distribute educational materials in the States. And what they say, among other things, is virtually all of us possess the ability to be literate in the shared language of math. Math is not just for calculus majors. It's for all of us. And it's not just about pondering imaginary numbers or calculating difficult equations. It's about making better daily decisions and hopefully leading richer, fuller lives. Oh, well, sounds good. How does that work? Well, we've had many discussions about how that might work at this conference today, and I hope to continue that discussion. But before getting into those details, I would like to remind you that this impression that math is like this has not always been the case. So, for example, in 1781, Samuel Johnson is writing a very nice biography of Milton, in the sense that he thinks Milton is wonderful. I read the biography and came to the conclusion that Milton was a bit of a monster. But nevertheless, he says, in here, he says, the truth is, knowledge of external nature in the sciences are not the great or frequent business of the human mind. The first requisite is the religious and moral knowledge of right and wrong. And then comes history. Prudence and justice are virtues and excellencies of all times and of all places. We are perpetually moralists, but we are geometricians only by chance. Our intercourse with intellectual nature is necessary. Our speculations upon matter are voluntary and at leisure. And the idea is that if we take this distinction seriously, we are led to conclude that while math, well, you know, so then he says everybody needs to take poetry, rhetoric, and history. Okay, those should be the classes in the core curriculum, because we don't all need to be good at math, but we do all need to be good. Now, can you imagine trying to sell this argument for a revision to the core curriculum to contemporary administrators? You would get nowhere, for various reasons, and we can talk about those later. Okay, so that's my very brief historical survey. We could talk more, but I want to move to part 2. Here's what I think. Mathematics and morality are neither created nor discovered, but are cultivated social practices. The co-adaptation of cognitive capacities, such as abstract and analogical, there should be the word reasoning there, makes both mathematics and morality possible. Both are cultivated in such a way, however, that we come to regard them as independent of any actual human activity, even as they are thought to govern and constrain all possible human activity. Which, if you think about it, is really rather strange. But this is the perception, right? So, not everybody likes this idea. Frege famously did not like this idea. He wrote in a post-Darwinian context. He had read John Stuart Mill's arguments that mathematics is something we acquire over time by interacting with the world, and he thought they were nonsense. And here's why. If everything were in continual flux and nothing remained fixed and eternal, then knowledge of the world would cease to be possible and everything would be thrown into confusion. Okay? And some of you are familiar with that. Okay? And then here's what I want to do. I want to draw an analogy between Frege's concerns with John Stuart Mill's claims that math is something we acquire by interacting with the world, with Albert Mohler's concerns about evolutionary theory. Now, he's the director of Baptist Theological Seminary, and he says, if human beings are not made in the image of God, and if the entire cosmos is nothing more than a freakish accident, morality is nothing but a mirage, because morality has no objective basis. Human life has no inherent dignity, and we are alone in the universe to eat, drink, and be merry, before our bones join the fossil record and we pass from existence. That sounds lovely to some and simply horrid to many others. Now, my claim is that these objections, both the objection of Frege and the objection of Moeller, are two species of the same genus. If everything were subject to change and nothing remained fixed and immutable, mathematics would be possible and morality would no longer have an objective basis. But mathematics is possible. And since we are able to make genuine mathematical discoveries, not despite, but because of our cognitive differences, I have a paper, I read it in October, I can get it to you if you want, then should we not be able to make genuine ethical discoveries in light of our cultural and personal differences? Okay, so that's my bold hypothetical. Okay, and this also is inspired to a certain degree by Piaget. He says the mere fact of individuals living groups is sufficient. Okay, if we're social, that's enough to give rise to new features of obligation and regularity. A rule is therefore nothing but the condition for the existence of a social group. And if to the individual conscience rule seems to be charged with obligation, this is because communal life alters the very structure of consciousness by inculcating into it the feeling of respect. Okay, in other words, moral norms may indeed have evolved over time, but in such a way that we now think that they are independent of our social circumstances and human history. This argument has also been made about mathematics by Lakoff and Nunez in their book, Where Mathematics Comes From. I have a lecture on my difficulties with the book, but the thing I really do like about the book, and I think they're exactly right, is their claim that it follows from the empirical study of numbers as a product of mind that it is natural for people to believe that numbers are not a product of mind. And so this is another important analogy between mathematics and morality. Now, one of the reasons why I like to talk about the relation between these and the cognitive capacities that give rise to our capacity for moral reasoning is that if we look at the developmental stages proposed by Kohlberg, a student of Piaget's, he said, look, we start off in a pre-conventional stage where all we want to do is avoid punishment and play well with others. And then as we develop in our cognitive and analytic capacities, we then learn to follow rules and fulfill duties towards others. And then, as we continue to develop, we enter into a post-conventional moral phase where we are able to enter into social contracts and cultivate universal ethical principles. And I believe that mathematical education of children is essential to help people get from conventional to post-conventional reasoning about morality. Now, Carol Gilligan came up yesterday, and you might be saying, but wait a minute, why are you talking about Kohlberg? Carol taught us that he was full of nonsense, right? No, of course not. That's not what she taught us at all. She was his colleague and worked with him, and what she actually showed is that his understanding of post-conventional moral reasoning was, in the 1970s, very androcentric, in that it coded some of the moral reasoning of women and girls as somehow unable to reach the higher stage. But that's not true. The relational care ethics that is developed in the time since Carol Gilligan's groundbreaking work shows that there are many kinds of post-conventional moral reasoning possible, and really, if you want to understand their similarities and differences, you better have some maths. You better have the ability to reason about relations with two or more variables in them, universal instantiation and universal generalization, particular instantiation and particular generalization. If you want to develop a post-conventional relational ethics, these are the mathematical skills you require. And I believe that Professor Gilligan would be very sympathetic to my project. She writes, it's in an interview in 2008, she said, it's interesting that In a Different Voice is still in print because it should be outdated. Women's voices should have transformed the conversation. So part of what I see myself as doing is trying to transform the conversation, especially the simplistic conversation, which says Professor Gilligan taught us that Professor Kohlberg was wrong about everything, because that's not actually what she taught at all. And here's what she says: if we want to change the world, it means becoming active in making the world one in which the capacities that are part of our human nature, that is, the relational capacities that are necessary for democracy and peace, can be educated, developed, and flourish. That's what I want to see happen. Now, Frans de Waal is a primatologist. When you argue that morality is something that evolved over time, people say, yes, but only humans have it. It comes out of nowhere, so it can't have it. It couldn't possibly have evolved. Except, of course, it doesn't come out of nowhere. And Frans de Waal's work shows us that there's these proto-ethical practices in primates. Well, you know, it's reciprocal altruism and inequity aversion. You know the inequity aversion studies, right? You can get a chimpanzee to perform a task for a bit of cucumber until such time as the chimpanzee sees another chimpanzee getting a grape or a sweet for doing the same task, and then the chimpanzee will not do it for cucumbers any longer. In fact, they will throw the cucumber at the investigator. It's on YouTube. Look it up. It's hilarious. I highly recommend it. Now, what he argues is he says that moral reasoning is both abstract and relational. He says a human being growing up in isolation would never arrive at moral reasoning, echoing Piaget's claim. He says a Kaspar Hauser would lack the experience to be sensitive to others' interests and hence lack the ability to look at the world from any perspective other than his or her own. I consider this level of morality, with its desire for consistency, a mathematical virtue, and disinterestedness, another mathematical virtue, and its careful weighing of what one did against what one could or should have done, also mathematical skills, to be uniquely human. De Waal has this tower of morality, and I show this picture. He's got the self at the top, family, community, tribe, humanity, and all of their life forms. And this tower floats in a sea of resources. And as the resources are more available, the tower can float up and you can care about more things. And as the resources dwindle, you sort of have to scramble up to the top and you can only start to care about yourself. Now, my goal in showing this picture is not to claim that, yeah, he's got it, that's how morality works, but to say that if you want to understand pictures like this, you need mathematical abilities, including the ability to interpret graphs and pictorial representations of things like the relation between moral reasoning and the availability of resources. And so one of the reasons why one of the ways I teach this to my students is I ask them the question, would you eat a dog, does not have a simple yes or no answer. And they say, no, of course it does. I would never eat a dog. And I'm like, no. The question is, would you eat a dog depends on how hungry you are and what other food is available. Because while it certainly seems in our culture repugnant to imagine eating a canine, there is also not too difficult an exercise of the imagination to imagine scenarios where you most certainly would eat a dog, okay? Or at least you would most certainly make your children eat a dog so that they could survive. If that was all that was on offer. Okay, wrong direction. So here's another hero of mine, Ernst Mach. He wrote in an essay, in his book on popular scientific essays on the economical nature of physics, I think it applies to mathematics and morality as well, he says all so-called axioms are instinctive knowledge. The greatest advances of science have always consisted in some successful formulation in clear, abstract, and communicable terms of what was instinctively known long before, and of thus making it the permanent property of humanity. Okay? So, what do we need to do to make moral progress? We need to find axioms of prudence. Those very things that Samuel Johnson was talking about that have fallen on hard times, not just in the provost's office, but in the humanities departments as well. Okay? And also this applies to mathematics, as Poincaré reminds us. He says, one only has to open one's eyes to see that the triumphs of industry, which have enriched so many practical men, would never have seen the light if only these practical men had existed, and if they had not been preceded by disinterested fools, who had died poor, who never thought of the useful, and yet had a guide that was not their own caprice. What these fools did, as Marquez said, was to save their successors the trouble of thinking. And this, I think, relates to Sasha's point about how we are now precariously dependent upon devices that rely on mathematics that we do not necessarily understand. It's part of our inheritance. I've come down with a bad case of Poincaré, and I think he has a lot of interesting things to say, and he makes this connection between mathematics and morality as well. And one of the things he notes, and this is part of the point of my argument, you say, well, if mathematics evolves, how can that be when people are so different with respect to mathematical ability? And how can you say that morality evolves if people are so different with respect to their ethical intuitions? And then I would just remind you that you have to have variation in order to have natural selection, right? So these differences, they're not an obstacle to be overcome, they're a necessary condition that must be in place in order for any natural, or in the case of cultivation, artificial selection to come about. So Poincaré asked the question, how is it that there are so many minds incapable of understanding mathematics? And he says, the feelings on which ethics can be based are not found to the same degree in all souls. In some souls, some feelings predominate, while in others, other strings are always ready to vibrate. All these tendencies are praiseworthy, but they are different. In some, there are many ways of being good. And then there's this long passage, and this is the focus of the talk I referred to earlier about the diversity of mathematical minds, kinds of minds, and how they're essential for mathematical progress. But what he says is, first of all, many children are incapable of becoming mathematicians who must, normative force, the less be taught mathematics. And here I agree with Poincaré rather than Emile. Because of the morality dimension. He says, the mathematicians themselves are not cast in the same mold. It is useless to seek to change anything in this, and besides, it would not be desirable. We must resign ourselves to the diversity of minds, or rather, we must be glad of it, because it makes progress possible. Okay, so the talk of the other paper to which I was referring to, I give the talk in French because I think it's nicer. L'uniformité, c'est le mot. Okay, let us guard against imposing uniform methods on all. That is unrealizable, and moreover, it is not desirable. Uniformity is death because it is a door closed to all progress. Okay. Now, part 3. I'm on time. What pedagogical strategies follow from the ubiquitous analogies between mathematics and morality as inherited cognitive capacities and intellectual traditions that vary over time and across cultures? If all students must learn math, because we are perpetual moralists who reason by abstraction and generalize about necessary constraints on possible relations, what kinds of lessons should we assign to students? Okay? And this is the really important question. We've all sort of been sneaking up on this question these last 3 days, and I have some concrete suggestions. For one thing, Rafael Núñez, in a recent interview, says there's a tendency on the part of administrators to sort students into different groups and to say, oh, well, if you're artistic, you don't need math, or yes, you are mathematical, so you take math. And he says we miss the opportunity of developing people in a more integral way, a way that would be more conducive of transdisciplinary dialogue, okay? And he makes the normative claim, which I should very much like to endorse, which is newer generations need to be formed differently. That is, even if this has worked for us in the past, it's not going to work in the future. Okay, so David Wagner is a math education professor, and he is primarily interested in math as a social practice and how it relates to social justice concerns. So, my kind of guy. And he wrote an essay called If Mathematics is a Language, How Do You Swear in It? Which is a lovely essay. It was collected in a book called The Best Essays on Mathematics in 2010 or some such. And he says, knowing what mathematical expressions are not permitted helps us understand the ones that are permitted. Further, pursuing the non-permissible one opens up new realities. That is, we need to teach our children where the borders are and then give them the permission to transgress them. And in fact, when they transgress them, this is a good thing because the student who swears cares. The student who chooses a unique path is showing engagement in the discipline. And he's got a long quote, which I think is very nice. He says, the perennial student question, why are we doing this? May seem like a swear, as it seems to challenge the authority of the classroom practice. However, and this is right about this, it is the most important question students can ask. Though I find it somewhat disturbing when mathematicians and others ignore human particularities, it is important to recognize that this loss is central to the nature of mathematics. Generalization and abstraction are features of mathematical thinking, and they have their place in thoughtful human problem solving. There is value in asking what is always true regardless of context. There is also value in prompting mathematics students to realize how mathematics obscures context and to discuss the appropriateness of this obfuscation. Mathematics students should make unique contributions using the word I and conjunction, find ways of generalizing and losing the word I. When is it important to embed contextual details? When do we need to pay attention to them? These are the kinds of things that people should be doing in maths class. Okay, so G.W. Thompson is an advisor at Old Dominion University, and in 1981 he wrote a lovely paper called Teaching History, Mathematics, and Morality, an Integrated Approach. And he says, classroom teachers often find it both possible and desirable to teach social studies along with other subject areas. Since the interfacing of the discipline happens in real life, why can't it happen in the classroom? Okay, certainly history is replete with moral and social issues where the identification and resolution of those conflicts depended on mathematics. And the example he gives is one of a medieval wool village somewhere in the Cotswolds, and he says, suppose a widower loses the supplementary income from his wife's spinning. Shall he be permitted to graze more than his fair share of sheep on the commons to make ends meet? Well, it's an open moral question, but one that you cannot understand if you don't understand the mathematics involved. If the land can only support so many sheep, and if there are a certain number of villagers, and it has been decreed that each member of the village gets a certain number of sheep on the land, then the answer is no, he's not permitted to graze more than his fair share of sheep, on the one hand. On the other hand, he's lost income because his wife's spinning, which used to bring in money to the house, is no longer available to him. So in this way, you can teach questions of mathematical resources and distribution of common goods throughout a community and social studies at the same time. Now, just because you can integrate math and social studies doesn't mean it always works. In January of 2012, there was a very famous, what I call, integrated lesson plan fail in Georgia. On Wednesday, 9 third grade math teachers at Beaver Ridge Elementary School were attempting to do a cross-cultural activity with a book the children had read about abolitionist Frederick Douglass in their social studies class. And the first math question asked, each tree had 56 oranges. If 8 slaves picked them equally, then how much would each slave pick? And the other said, if Frederick got 2 beatings per day, how many beatings did he get in 1 week? Needless to say, the homework went home, the parents were appalled, as was the nation. But the point I would like to make is this. Just because some integrated lessons in social studies and math fail on moral and perhaps mathematical grounds, that is not an argument against the failure of all integrated lesson plans. It's like the Ted Kaczynski rebuttal. All students need to learn mathematics. Yes, but Ted Kaczynski, So this example functions similarly. I say we should do a better job of integrating social studies education and maths education, and people say, what, like they did down in Georgia? And I say, no, this is not what I have in mind. Fortunately, Judith Grabner has given us a bulleted list of 5 desiderata that we want our integrated maths lesson to meet, and I only have 2 here because of time, but here's the website if you want to go read the whole article, and I recommend that you do. And the first one is to go slow, so as to avoid the low-level use of high-level skills that results from rushing through material too quickly in an effort to get people to pass a test, for example. In solving real-world problems, I encourage the students to practice the reverse, the high-level use of low-level skills. And I think this is what the kind of mathematical reasoning that goes on in the sheep village example. That's low-level mathematics, but it requires high-level reasoning to make sense of the problem. And then, another one of her desiderata is to teach important mathematics. And figuring out what that is, I think, part of our job. I think, let's not debate about whether or not we need to teach math. Let's agree we need to teach math because we are perpetually moralists, and then move on to the next most important conversation, which is, what is the important mathematics that all the children need to have in school? And one of the things she suggests is important is the philosophical implications of statistical and probabilistic reasoning, including the ethics of cost-benefit analysis and the question of free will versus determinism. And I think the ethics of cost-benefit analysis is part of the important mathematics that we heard about in Timothy's talk yesterday. Okay, so I am almost done, and there is a graphic on your handout, and this graphic was developed by Otto Neurath. Otto Neurath was an Austrian economist, sociologist, and philosopher, a member of the Vienna Circle and the Unity of Science movement. He's famous for his claim about Neurath's boat, which is to say all of us are in the same boat, and the boat is the knowledge that we have inherited, but the thing you need to remember is there is no dry dock. All of the repairs that we make to our knowledge we must make while we are at sea. And he's right about this. I've looked into it. There is no dry dock. Okay? And one of the things that he sought to do, he shared my intuition about the relationship between mathematics and morality and the importance of education, though his focus was on adult education, because at the time there were many adults in Vienna who lacked formal schooling and who were illiterate and illiterate, and he said, how can we get the citizens to make informed choices in a democracy when they lack basic numeracy and literacy skills? And his solution was to develop the isotype language. He said the basic aim of this visual method is to humanize and democratize the world of knowledge and of intellectual activity. So, isotype involves, well, at the time they had to actually carve the blocks, right? Involves the repetition of individual symbols that stand for certain numbers, because if you just give people numbers, they begin to look alike. It is not natural for us to be able to see differences in numerals. However, if you make its symbols stand for numerals, it is in our nature to see relative comparisons of greater than and less than, and that comes naturally. Take a room full of toddlers and give them all sweets, and give one of them a really big cookie and give the rest of them like a small, little biscuit, and then watch the howls of protest. I mean, this they can do. No training required. And so he said, if this is our native ability to recognize greater than and less than, let's exploit that to make arguments. And here is a visual image. I mean, the picture is not entirely self-explanatory, but it could be used in an argument for the claim that war is bad for children and other living things. What we see here is this line represents an origin, and every baby born, every 250,000 babies born represents another little infant to the right, and every infant that dies in the same year is a coffin that goes back towards the left. And what we notice is that in Germany from 1915 to 1918, there were more coffins than there were infants. Okay, so they're casualties of war. We're often, we're aware of the casualties of war when we talk about the loss of lives of soldiers, but that's just the tip of the iceberg. Okay? The effects of war are much more far-reaching. And this kind of graphical illustration is what Neurath had in mind when he thought we could do a better job of communicating complex statistical data to larger communities of people as part of a larger project of the democratization of knowledge. And so, why motivate math using moral examples? Why cultivate morals using math examples? He says in his essay, Visual Education, A New Language, in this way, learning is not limited to acquiring facts necessary to pass examinations and then not using these facts again. We've despaired of this approach to math education for 3 days now. However, if you adopt this other approach, students are led to understand the relationships of the facts within one subject field, and, even more important, they are enabled to see how one division of knowledge is related to the facts and the theories in other fields. Now, there is still a political dimension to this, and you say, okay, but I'm not yet convinced. What is your ultimate motivation for adopting this? And I can't say it better than Lancelot Hogben said in 1937 in his book, Mathematics for the Million. He says, the most brilliant intellect is a prisoner within its own social inheritance. Okay, so he's read some Mach, takes it very seriously. Beyond a certain point, clever people can never transcend the limitations of the social culture they inherit. When clever people pride themselves on their isolation, we may well wonder whether they are so clever after all. To be proud of intellectual isolation from the common life of mankind and to be disdainful of the great social task of education is as stupid as it is wicked. No society, least of all so intricate and mechanized society as ours, is safe in the hands of a few clever people. Okay? This is what I believe. He's right. So, in conclusion, to paraphrase Locke, I am bold to think that morality is as capable of cultivation as mathematics. We can make progress in both disciplines. In evolutionary terms, mathematics and morality are neither created nor discovered, but inherited, with variation, from one generation to the next throughout the human family. Our diverse moral and mathematical minds need each other more than either discipline needs to be understood as externally derived, uniformly instantiated, and ultimately independent of the course of human affairs. And finally, we need to value math education if we want to make moral progress, just as we need to value intellectual variation if we want to make mathematical progress. Thank you very much.